Hi guys, I'm Nancy, and I'm going to show you how to use the basic trig functions and how to find the values of the 6 basic trigonometric functions. So that is sine, cosine, tangent, and their partners, cosecant, secant, and cotangent. So first we're going to look at just sine, cosine, and tangent. And we're going to use the memory trick SoH CAH TOA, which a lot of people say quickly as SohCahToa. But this is what it is. It's a memory trick to remember what sine, cosine, and tangent mean. So we'll use that. All of these 6 trig functions involve right triangles. That is, triangle that has a right angle in the corner, which is noted by the corner symbol down here. So it's 90 degrees, a right angle. And you will also know where theta is. It will be labeled on your triangle. Theta is just an angle. It's an angle that is not your right angle. What's important to know is what each of the sides of the triangle are in relation to theta. What I mean by that is the longest side on the triangle is called the hypotenuse. So you'll just want to remember that the longest side is the hypotenuse. The other side that is next to theta, that is not the hypotenuse, is called the adjacent side. It's adjacent to theta, but it's not the hypotenuse. And the other side, the third side, is opposite theta, directly opposite theta, and it's the opposite side. So notice that the hypotenuse is immediately opposite the right angle, the opposite side is opposite theta, and then the adjacent side is the other side next to theta that is not the hypotenuse. So you will use those to evaluate sine, cosine, and tangent. So you might be working on a problem that looks something like this, where you're given triangle, you write triangle, the right angle, some theta labeled on your diagram, and then side lengths that are given to you. So for instance, you might be given that the longest side, the diagonal, is 5. This side length could be 3, and this side 4. And then the question might be find sine of theta, cosine of theta, and tangent of theta. So let's find those. Sine of theta is equal to opposite over hypotenuse. So this memory trick, SohCahToa, can help you know what values to use for sine, cosine, and tangent. For sine, it's going to be opposite over hypotenuse. It's the so part of the memory trick. So sine equals opposite over hypotenuse. So I'll write that out, opposite over hypotenuse. And in this particular problem, the opposite side is 4. This is directly opposite theta. So you put 4. And the hypotenuse, the longest side, is 5. You put 5. So your answer for sine of theta is 4/5. In the same way, you can find cosine using your memory trick. The acronym SohCahToa. So cosine is the CAH part of this trick, CAH. And that stands for cosine equals adjacent over hypotenuse. Cosine equals adjacent over hypotenuse. And so in this problem, the adjacent side to theta is 3. And the hypotenuse is again 5. So your cosine value is 3/5. And then finally, if you have to find tangent of theta, just remember this part of the name SohCAH TOA, the TOA part, TOA, so tangent equals opposite over adjacent. The opposite side in this triangle is 4, and the adjacent side is 3. So you have 4 over 3. So your tangent of theta equals 4/3. Okay, say you actually need to find the values of cosecant, secant, or cotangent, one of the other 3 basic trig functions. The easiest way is to first find the value of their partner trig function, sine, cosine, or tangent, and then take the reciprocal, 1 over sine, 1 over cosine, 1 over tangent. So let me show you an example. Say you wanted to find cosecant of theta, COC theta. First, find its partner, sine of theta. And in this example, sine of theta, remember, is opposite over hypotenuse from SohCAH TOA. Sine is opposite over hypotenuse. So in this triangle, it is 4 over 5. Cosecant of theta is, by definition, 1 over sine theta. And what that really means is that you can just flip numerator and denominator of sine, flip top and bottom. So instead of 4 over 5, it's 5 over 4 for cosecant theta. So your cosecant theta equals 5/4. Now, if you wanted to find secant theta, SEC theta, you would first find cosine theta. In this triangle, remember cosine is adjacent over hypotenuse. So here it's 3 over 5. Then, to get secant theta, SEC theta, you would take 1 over cosine theta. And that can be found just by flipping top and bottom. So instead of 3 over 5, 1 over that would turn out to be 5 over 3, the reciprocal. So we have secant theta's value is 5/3. And then finally, if you wanted to find cotangent theta, you would first find tangent theta. So tangent theta is opposite over adjacent. So in this triangle, it's 4 over 3. And then, to get cotangent, you would do 1 over tangent, which is the reciprocal of this value, so it's 3 over 4. Cotangent of theta is 3/4. That is the fastest, easiest way to find cosecant, secant, and cotangent. Okay, I want to show you some things that can trip people up. One thing that confuses people is when the right triangle is drawn at a different orientation. So if it's sideways or on its hypotenuse. So for instance, you could have a triangle that's drawn like this. It's still a right triangle, but it looks kind of upside down. Your theta could be here. You could have a triangle that looks like this. So it's the reverse of the one in our example. You could have a triangle drawn with your theta up here instead of down here. And the one that's most confusing to people is when the right triangle is drawn so that its hypotenuse is horizontal instead of on the ground. So here's an example of that. If your right angle was actually up here, then your hypotenuse turned out to be horizontal. And your theta could be here or here. So let's look at these examples and label where opposite, adjacent, and hypotenuse are for these triangles. In this example, in all of these triangles actually, you can rely on your hypotenuse being the longest side. So in this triangle, you can still tell that this is the longest side, so it would be your hypotenuse. The other side that's next to theta is still your adjacent side, so this would be your adjacent. And then the other side that is opposite theta, directly across from theta, is opposite side. Let's label these as well. So across from theta is your opposite side, longest side is your hypotenuse, and the other side next to theta is your adjacent. Over here, your adjacent is this side, your opposite is down here, and your hypotenuse is the longest side. Okay, down here, longest side still your hypotenuse, the one that's opposite the right angle. The one opposite theta is your opposite side, and then the other side next to theta is your adjacent. There's one more thing that trips people up in these problems when you're finding the value of trig functions. When you write your final answer, make sure you put theta. You don't want to write something like this, that your sine equals 3/5. You want to write sine of an angle, sine of theta equals a number. If you don't write the angle, this doesn't have any meaning. I know a lot of people forget it. I get it. I know it's a lot to remember, and these trig functions are all new and weird. But if you don't write the angle, it doesn't really make sense. It doesn't really have any meaning. So make sure you write your full answer as sine of an angle, cosine of theta, tangent of theta, or tangent of x, whatever your angle is called. I hope that helped you understand sines, cosines, tangents, cosecant, secant, cotangents. I know trig functions are super fun. It's okay. You don't have to like math, but you can like my video. So if this helped you, please click like or subscribe below.